Hey everyone, in this video I'm breaking down all of Chapter 1 of Algebra 2 into one video so you can ace your next test. If you're new here, my name is QC. I finished Algebra 2 with straight A's all year and scored a 32 on my math pre-ACT, so you could say I'm pretty qualified to talk about this stuff. Without further ado, let's dive straight into it. Starting off, something you need to know is parent functions. The most common ones are constant, linear, absolute value, and quadratic. Constant functions are really written as f of x or y equals -1. Shown here, this is what the graph would look like. The domain would be all real numbers, and the range would be y equals -1, which is where the y-intercept is here. Linear functions can be written as f of x equals x, and it looks like this, which is basically a straight line. The domain is all real numbers, and the range is all real numbers. Absolute value equations can be written as f of x equals the absolute value of x, drawn as this, which kind of looks like a V. The domain is all real numbers, and the range is y is greater than or equal to 0. Quadratic equations can be written as f of x equals x squared, drawn like this, kind of like a U. The domain is all real numbers, and the range is y is greater than or equal to 0. Parent functions are functions that have 0 transformations applied to them, and we will talk about transformations next. So starting off with number 1, we have a parent function graph on the left and the transformed graph on the right. So a linear function can be written as this, but you are more common to see like this, where m affects the slope and b affects the y-intercept. So what differs from here to here? So starting right away, I see a 2x compared to a 2, so I see a vertical stretch by a factor of 2. Then I also see plus 2, which we also see here, 0, 2, where this one is 0, 0. So I see translation up 2 units. That's basically it. Next up, we are given a table, and we are given x values, output values for f of x and g of x. We are given that f of x is a quadratic, so we know, which is also written as x squared, so we know that g of x will also be x squared. Now, to find what the transformation is, we can do the output values of g of x divided by the output values of f of x. So we can go 4 over 16, which comes out to 1 over 4 when you simplify the fraction. And then we can also go 1 over 4, which is just 1 over 4. So getting that, we get our transformation, which just gives us 1/4 x squared. And we can check this by going here and using the x and putting that back into the equation. So say 1/4 2 squared from right here. We would get 4 times 1 over 4, which equals 1, because these both cancel out. And that lines up with our g of x output value right here. Now let's talk about transformation notation of a quadratic and an absolute value equation. So for a quadratic, it is a times the quantity x minus h squared plus k, where a affects the slope, h shifts it horizontally, k shifts it vertically, with the vertex being at h, k, and the axis of symmetry being h. For an absolute equation value, it is a times the absolute value of x minus h plus k, where the vertex is h, k, and the absolute value, axis of symmetry is at h. Now let's get into some practice problems. If you want to try these practice problems, state the axis of symmetry, the vertex, what family this is from, and the transformations applied. Alright, so 3.1, we are given a vertical shrink of 1/2 with a translation to the right 2 units and up 4 units. So that would give us a vertex of 2, 4 with an axis of symmetry at x equals 2. Next up for 3.2, we have g of x equals the absolute value of x plus 2. So I don't see any a value or k value. However, I do see plus 2. And since the equation is written as x minus h, this must be negative. So the vertex is at negative 2, 0. And the axis of symmetry is at x equals negative 2. Last one. H of x equals 4 times the absolute value of x plus 3. Right away, I'm seeing a vertical stretch of 4 and no h value. However, I do see a k value of plus 3. So our vertex will be at 0, 3, where the axis of symmetry is at x equals 0. Oh, I forgot to mention the family. Number 3.1 is a quadratic. Number 3.2 is an absolute value, and so is 3.3. Unit 2 of Chapter 1 is more focused about the translations and the transformations, as well as writing functions, with also writing functions with the combinations of transformations. Question 1 reads, write a function f, I'm going to say g of x with a reflection in the x-axis and a translation up 5 units from the parent function f of x. F of x is right here, and from a transformation notation of a quadratic, a reflection in the x-axis, we want to make a negative, because if we made x negative, that would reflect on the y, which is not what we want. And a translation up 5 units, we would want to make k 5. So we would go g of x equals negative parentheses x squared equals, plus 5. Now, something important to keep in mind, if you were, say, translating it to the right 2 units, it would be h. So you would do g of x, let's just do the same thing, equals negative x squared, x minus 2, because you're going to the right, plus 5. Now this is wrong, because this actually reflects it across the y, which is not what we want. So we want to erase this, and actually we want to write it as negative the quantity x minus 2 plus 5, because then that actually translates it to the right. Alright, next up we have write a function g of x with a horizontal shrink of 2 of the function f of x, then translate it left 6 units. So first I see horizontal shrink, and then translation left. So that means we want this way, or a negative h. And a horizontal shrink of 2 is kind of weird. They're like counterintuitive, so it would technically just be 1/2. You'll see what I mean later. So for g of x, we would write g of x equals 1/2 x plus 6, because we know it would be x minus h. So to make it go left, we would go negative 6. That's how we get this. So then we would just factor this, get rid of this 1/2 by multiplying by 2. So then we get g of x equals 2x parentheses, I forgot to square this, plus 12 squared. And that is your final answer. Next question, number 3. Write the equation f of x, this equation here, with a reflection in the y-axis, and translate it up 5 units. So the first thing I'm seeing is a reflection in the y-axis. So like we talked about previously, we would not want to write this as x plus 1, because that would be wrong. We would want to write this as, I'm going to write this as g of x. We would want to write it as negative times negative x. And then up 5 units, we would just add 5. So negative 1 plus 5 is 4. This is your final answer. Unit 3 of Chapter 1 is pretty short. It really just includes writing equations of linear functions using points and slopes, as well as point-slope form, and finding lines of fit in the lines of best fit. Alright, so to start off, we have slope-intercept form, which we already talked about, y equals mx plus b. However, we have not talked about point-slope form, or m. And point-slope form is y minus y1 equals m times x minus 1. M is equal to y2 minus y1 over x2 minus x1. So let's start with two examples. First example, find the slope between the points 1, 4 and 3, 12. So right away I'm thinking m, because we are given these 2 points where 12 is y2, 3 is x2, 4 is y1, and 1 is x1. So to rewrite that, we would just do 12, which is y2, minus 4, which is y1, over 3, which is x2, minus 1, which is x1. And if we simplify, we get 8 over 2, which is equal to 4. So our slope here is 4. All right, next up we have write the equation of a line that passes through 2, 1 with a slope of 3. So right away I'm thinking point-slope form because we are given a point and the slope. So to start off, let's label our x1 and our y1. So 2 would be our x1 and 1 would be our y1. And I'm just going to write up here so we have more space. So plugging this all in, we get y minus our y1, which is 1, equals m, which is 3, times x minus x1, which is 2. Now to solve for y, which is what we do for slope-intercept form, we would distribute this 3. So distribute to the x, distribute to the negative 2. So you get y minus 1 equals 3x minus 6. Now to solve for y, you just want to add 1 plus 1 plus 1. So these will cancel out on the left side, and you get y equals 3x, negative 6 plus 1 is negative 5. Now if you want to check this, you can just plug this point back into the equation. So we would do 1 equals 3 times 2 minus 5. 3 times 2 is 6 minus 5, which equals 1. And this checks out. So this is our final answer. Alright, so we have this equation, this table, and we have 3 questions. Number 1 says create a scatter plot of the data. Number 2 says sketch a line that closely fits the data. Number 3 says choose 2 points and find the slope, then create a line of best fit. So to start off with number 1, I created a graph, and I'm going to now graph those points. So now that I have number 1 finished, I'm going to do number 2, sketch a line that closely fits the data. I'm going to start at this point and try to associate as many points as I can. So I think a line like that would be good. Alright, lastly, number 3, choose 2 points and find the slope, and then create a line of best fit. So for something like this, I would recommend 2 points that are really far away, because if they're really close, it's not going to create a really good slope. So let's go with 50, 195, and let's say 37 and 162. I'm not sure if that'll be a good number. However, let's try it. Okay, so let's write down those numbers. 50, 195. This will be our y2 and x2, since these are the bigger numbers. And then we can also write 37, 162. This will be our y1, x1. So now we can put this into our slope our m equations. So 195 minus 162 divided by 50 minus 37. So this is equal to 33 over 13. Let's see what that is. So that is about 2.5. And it says, then create a line of best fit. So we don't have exact points here, but so we have our m here. So then we could use point slope form, and we could go, let's just use 50 and 195. So then we could do y minus y1, which would be, this is now going to be y1. So 195 equals 2.5 times x minus 50. So then we get 195 equals 2.5x, and 50 times 2.5 equals 125 minus 125. Now we want to add 195 to each side. Plus 195. 320. So then we get y equals 2.5x plus, or excuse me, it would be 195 plus negative 125. So we get 70. So what do we do with that? We would go here at roughly 70 and then draw our line. This is not exact. And with a slope of 2.5. And here, this is 0, 70. There we go. So 1.4 in Unit 1 is really where the fun begins, because this is solving systems of linear equations in three variables algebraically, which is existentially harder than 1.1 to 1.3. But let's get into it. Alright, so to begin, we have our three variable system here with three equations. So what we need to do is, we need to eliminate one variable so that we can solve for the other two. What I mean by that is finding an equation that will easily be eliminatable, if that's a word. So right away, I'm seeing a negative y here and a positive 2y. So we could multiply this equation by 2 and eliminate here. So I'm going to pair these two equations up. Same with this one here. You don't need to do anything here. All you need to do is just multiply this one by a negative 3. Then you would have 3y minus 3y. And those would cancel out. So I'm just going to pair these up. Alright, so next up, to eliminate the y, I'm going to multiply this whole equation by 2. And I will rewrite this as 12x minus 2y plus 8z equals negative 6. So now we can eliminate the y's and then just add down. So we get 4x plus 12x equals 16x. 3z plus 8z is 11z. 12 plus a negative 6 is equal to 6. Now here, we have to multiply this whole equation by a negative 3. So we get negative 18x plus 3y minus 12z equals 9, because a negative times a negative is a positive. And now we can add down and eliminate these y variables. So 2x plus a negative 18x is a negative 16x. 5z plus a negative 12z is equal to negative 7z. and negative 7 plus 9 is equal to 2. And something that I notice here is a negative 16x and a 16x. So these already cancel perfectly. And what I mean by that is if you rewrite it, it would be negative 16x minus 7z equals 2. And then we have 16x plus 11z equals 6. So then if you add down, these just go away. Negative 7z plus 11z is 4z. And then 2, that's a 2, plus 6 is equal to 8. Now to solve for z, we just divide by 4. And then z is equal to 2. And I'm going to put a box around that. Now, to solve for x, we can just plug it back into one of our equations. So I'm going to go back over here. I'm going to rewrite it up here. 16x plus 11z, which we know is 2, equals 6. So we get 16x plus 22 equals 6. Now to solve for x, we want to subtract 22. So we get 16x equals 6 minus 22 is negative 16. So we get x equals negative 1. Put a box around that. Oops. Now, to solve for y, all we need to do now is just plug back into the original equation. So I'm going to go back to the 6x minus y plus 4z equation because it's just going to be dividing by a negative. So plugging in, we get 6 negative 1 minus y plus 4z, which is 2, equals negative 3. So multiplying that all out, we get negative 6 minus y plus 8 equals negative 3. Combining our like terms on the left side, we get negative 6 plus 8, which is 2 minus y equals negative 3. Now what we want to do is subtract 2 to cancel it out on the left side. And we get negative y equals, I didn't mean to cross this out, negative 5. Now we divide by a negative 1, and we get y equals 5. Now for 3 variable equations, the ordered pair will be written as x, y, z. So our answer here will be x, which is negative 1, comma, y, which is 5, comma, z, which is 2. And this is our answer right here. All right, for the second problem, I'm going to do these two and these two because these looks like the easiest that I can do. One thing that you have to be careful about is you have to make sure that you eliminate the same variables or this will mess up how you solve for the equation. I've definitely done that before. So I'm going to eliminate the y's here and the y's here because that seems like the easiest option. So I'm just going to multiply this top equation by negative 1 and then this equation here by negative 5. So I'll start with the left. So all of this multiplied by negative 1, we get negative x minus y minus z equals negative 2. And then adding that down, the y's cancel. Then we get 3x minus 4z equals negative 8. Now over here, we will get negative 20x minus 5y plus 15z equals 30. So our y's cancel. Adding down, we get negative 15x and 15z plus 5z is at 20z. Then adding down, we get 30 plus 3 is 33. Alright, so I've rewritten it up here, just so you guys could see that. Alright, so it doesn't really matter what we solve for, because either way, no matter how we multiply this, both of these are going to cancel out. But let's just multiply by 5, because that'll make it easy. So then, multiplying all this by 5, we get 15x minus 20z equals 40. And then adding down, these cancel, so we get 0 equals 70. It's supposed to be a negative 40. So then we get a negative 7. And 0 does not equal negative 7. So this has no solution. Similarly to this, it's kind of like getting an equation like 3x plus 6 equals 3x plus 9. No matter how you slice it, when you subtract 3x from each side, these are just going to cancel. And then you get a false statement like 6 equals 9. That does not equal 9. And you can just stop here. The answer here is just no solution. And that's the end of the Algebra 2, Unit 1 review. If you enjoyed, please subscribe. I will be linking a video you might like right here. It covers SAT questions. And pretty soon I will be dropping a Algebra 2 Unit 2 review. And please subscribe if you want notifications about when I post that. See ya.